guys enjoy? Did you enjoy the one where you had to rewrite your answer from that?
No, I was like,
I was hella scared when I came in.
oh,
I'm like,
shoot, I'm X'd out
I
everything.
just flipped me through it. I'm like, dude, it took me forever. I didn't take down the notes for the D level set, the rice and everything. I just spent 2 hours doing that on paper before I ever went to the other seminar. So I'm so happy I had that ready. I just kind of like blacked out everything I didn't need or anything like that.
And then I was like, the transition from this school to that, rising independent. I know for sure I got I can't remember how to
For the assembly part of the class,
0 minus 1 equals 1
or x86, 60.
Yeah, but we're not.
It'll be X386.
down below.
X386. So we'll be using the enhanced mode instructions.
So it'll be 32-bit.
It'll be 32.
I got this from my hair, man.
I was looking at the book and I saw that it says x86, 64.
I'm just checking the
0 minus 1
checking my email, make sure that nobody says I'm sick, I cannot be here.
Is that for what?
That's what I worried about.
Alrighty.
Say there's a borrow 1. He said he only gives points. Professor, you only give points on the borrow bit, right?
Yes.
So if he has the result wrong, but he has the borrow right, does he still get points?
He will still get the answer. He will still get the points.
So you just have to say that
I put my borrow on the wrong,
Huh?
under the wrong row
and
added up the wrong number.
Yeah, well, I did ask for the result bits too.
Oh my god, that feels amazing right now.
Okay, what you got?
Alrighty. So let's go ahead and get this over with. Alrighty. So we'll spend as much time as you guys need to ask questions and stuff like that. Okay. So this is question number 1. Okay, guys. People behind you cannot see the screen.
That's the answer.
Yes. All right. So question number 1 is really a more complicated form of question number 1 in the practice exam. So basically, what you need to do is to track down what needs to be done in order for Q and /Q both to be 1s. Okay. So let's figure out. I'm just going to do it. Well, I cannot really do it on the board, but I can just kind of point out. Let me see what is the best way to do this. Do I have Zerno here? Graphics. I don't have Zerno installed. No. Sorry? The SR latch, they can both be 1s. There's one chance to make Q and /Q both 1s, but you need the input. You need this wire and this wire both to be 0s.
Yeah.
Okay, so then what we need to do is to track down what do we need, what is required to make one of them 0, and see if that will cause any problems. So track down this one. Track down the output of G2. If the output of G2 has to be a 0, that means both of the inputs have to be 1s, because this is an AND gate, this is not an AND gate, right? If both of the inputs of G2 they have to be 1s, then we have a potential problem of the other explanation is easier. The output of G2 goes into G3, so the 0 that we need out of G2 will go into one of the inputs of G3. But if 1 0 is going into G3, the output of G3 is going to be a 1. There's no way to fix that. So that's why G3, if G2 is outputting 0, G3 has to be outputting a 1. And as a result, there's no way to make the input into G6 to be a 0, and that's that explains it. Yep.
So we say that G2 has to output both a 0 and a 1 at the same time. That's why it's not possible. Would that be the correct answer?
That would be the correct answer, because if you need G3 to be a 0, then the output of G2 has to be a 1, but it has to be a 0 going to the other side, so it cannot be both a 1 and a 0 at the same time. Yep.
Is that considered a race condition?
No, it's not a race condition. It simply cannot happen. Just because of the way the gates are structured, that cannot happen. Yep.
Because like on my answer, I wrote in terms of the edge sensitivity. You can't have Q and /Q both be 1s.
Well, but you can. See, that's the thing. I mean, Q and /Q can, if you ignore this part of the circuit, if you ignore the edge sensitive part, they can both be 1s as long as both inputs are 0s.
Because I did say that like why those both can't be zero.
Yeah, you have to
So,
explain why they cannot both
Right.
be zeros.
That's fine.
Yeah. Yep.
On the question where you asked, like which two ones change, if you said, you said only.
Okay, let's move on to that question then. Okay, so question number two.
The right one.
Okay, are we done with question number one? Are there any further
Yeah.
questions? We are okay? All right, so we are moving on to question number two. Yep,
Do you give partial credit?
there will be some partial credit depending on, the circumstances. So question number two is only a 1 point question because, I figure it's actually a fairly simple one. So question number two is saying when clock is zero, when it is, not changing, it is at a zero. Even with the D line or the D port changing, Q and /Q do not change. Okay, that's the whole point of an edge-sensitive flip-flop. However, the state of at least one of the NAND gates will change. When I say that state is changing, that means the output is changing. Okay, so I'm asking which one is going to change and how is it going to change when the input pin D is changing while the clock line is a zero. Yep.
Okay, so you said which one? So if I pick, because actually two of them change. So if I said this one, I know for sure changes. Does that count technically?
That would be a partial credit because
But how do you partial half a point?
Huh?
It's like half a point.
Half a point, yes. Why not? I can give you guys partial points.
Okay, half a point. I'll take half a point.
Okay, Shane has not taken a class from me, obviously.
No idea.
Because I have like 1/7 of a point sometimes.
Really?
Yeah.
It's
Yeah.
like you're so wrong, but you're just enough right to where it's not.
Okay, so we want to track down what's going to happen when clock is zero first, okay? So when clock is zero, it is feeding into G2 and also G3 directly. So those are zeros feeding in. And when you have a zero in, then the output of G2 and G3 are guaranteed to be ones. So those two gates will not change regardless of what's going to happen with the D line. The D line, on the other hand, will change G4 because one line of G4 coming out of one of the input into G4 is the output of G3. The output of G3 is guaranteed to be 1. So as a result, G4 depends on D directly. And then the other one is G1. G1 has two inputs. One input is coming out of G2, which is guaranteed to be 1. And then the other one is coming straight out of G4. So these two, G1 and G4 both change depending on the D port, even when the clock line is a 0. Is that okay? All right. So that's the answer of question number 2. Moving on to question number 3. Okay, question number 3 is I was expecting most people just to copy and paste from their notes or their homework assignment or my notes or screenshot that I use in class. When any one of those would work, okay? So
I know, but I end up having to work.
okay, so we start off with the correct equation first. So Z0 is what I used in the first homework assignment. It is the result of adding the result of x0, y0, and then the sum of these two bits you have to add it to the carry in bit. So that is the original form, and then you have to expand the R. So you have to basically just go ahead and expand. I usually go with the inside first. So the inside one is going to be x0 not y0 plus not x0 y0. Okay. Then you expand the outer R. So the way I usually do it is like this. Cin is the last component, and then we have this entire thing as the inner component. So this is what I mean by step by step. All right, so with this one, there's really not a whole lot to do. The first term here, we just use distribution. Then it becomes x0 not y0 Cin plus not x0 y0 and not Cin. I forgot that one, not Cin here over here. There we go. Is that okay? And then the second part is a little bit more complicated because with the second part we have a negation on the outside of a disjunction, so you have to apply De Morgan's law first. So De Morgan's law goes like this. you negate whatever is inside, and then you change the disjunction into a conjunction. So it's going to look like that. And then the outside will still be a C in. All right, so, and I can cheat here because I can copy and paste. All right, so getting back to here, we have to distribute the negation into the conjunction again. So you basically just add negation to everything in the inside and turn the conjunction into disjunction. Same thing over here. Distribute the negation, turn the conjunction into disjunction. And if you want to simplify on the same line and just say, double negation goes away, that's fine with me. Okay, your simple stuff you can just combine on one. And then the last line is really the distribution again. So we distribute one more time, and this becomes not. Oh, okay. Hold on a second. We need to distribute first, and then distribute one more time. So we will separate those steps. So this becomes not x0 x0 plus not x0 not y0 plus y0 x0 plus y0 not y0. And then once we have this, we can simplify a little bit because we know that this term goes away because it is just 0. So we get rid of this guy. We know this one is going to be a 0, so we get rid of that guy, and then we just distribute. So now it becomes x0 not y0 not c in plus not x0 y0 not c in plus not x0 not y0 c in plus y0 x0 c in. And that's the end. That's it. Are there any questions about this one? It's all good? Yep.
Is it okay if we just call them x and y instead of x0 and y0?
Say again?
Is it okay if instead of calling them x0 and y0, we just call them x and y?
If it is clear to me, in other words, if it is in the right places. All right. So that's question number 3. Moving on to question number 4. Question number 4, I guess it's the reverse of the question in the practice test. In the practice test, I tell you what I want to do with the memory operations, and you tell me what needs to be done with the ports. So with this one, there's a little bit trick in it. Okay, so I want to see if you guys caught it. So the first one is easy. Okay, load is 0, clear is 0, and clear once it is 0, it doesn't change anymore. Because if clear becomes 1, we are just zeroing everything out in memory, which kind of is not very useful. Clock is low to begin with. Okay, so an LD equal to 0 means it is a write operation, which means we are intending to change the locations in the memory chip. The next line says, okay, let's turn on the chip here. Okay, so to make sure that the chip is paying attention, we specify 2D on the address line, which means this is specifying which location is going to be changed. And 50 is on the data line. But nothing is happening at this point. In step 2, absolutely nothing is really happening because in order to change the state of a memory location, it is depending on the rising edge on the clock. And there's no rising edge at this point. And then on step 3, I changed my mind. It's like, wait, I don't want to write 50. I want to write 60 to that location. But it's okay because the rising edge has not occurred yet, right? So memory has not changed. So on step 4, by the time we get to step 4, now we have a rising edge, and only at this time the memory location at 2D is going to change to not 50 but 6E. So 6E is the content in RAM at location 2D by the time we get to step 4. And then step 5 doesn't do much, it just resets the clock. And then without doing anything else, I specify a new location, 50, which is going to have a new content of 2D. I do a clock high, it is latching again. So now we have just written the content of 2D to location 5D by the time we get to step 7. So that's the second operation. And then the third operation is basically the rest. Okay, clock goes down to 0 again. And I stop driving the data bus. Okay, the CPU does not specify anything on the data bus because otherwise I will end up with a bus fight with the next step. Okay, So the next step of step 9 is turning the load pin high, which means I'm turning it from a write operation to a read operation. So right at this point, right at step 9, the memory chip is driving the output. Okay, but it's just a matter of, okay, the content of which memory location is it going to display or is going to be presented on the data bus. So right here at step 9, it is actually outputting the content of location 50. So it will be presenting 2D on the data bus right at step 9. And then on step 10, because I changed the address to 2D, they'll be outputting the content of 6D. Yep.
Do we need to mention that at step 9 it outputs 2D on the data line? Because I just said step 10 it outputs 60 on the
So
data
there'll be a
line.
minor nudge of points because step 9 is the point where it will actually output the content on of location 50, which is going to be 2D. So I think most people miss this one.
Yeah, I said that. I said output is 60.
Oh, you did?
Yeah.
2D.
What?
2D.
No, 6E.
No, 2D
No,
first
I know.
and then 6D.
Yeah, I
And
put the wrong one.
Does it matter what it's? Does it matter if you're telling it that it's outputting the content at that location,
wait.
or does it matter if
I
you
actually
say what content it is outputting?
You should specify both.
I
the
said
content
the chip
and
emits
the location.
the data at the location 2D, which is 6E. That's
Oh,
right.
I see. Okay, the content of location
Which is
60,
60.
65 is on the D port. Ah, okay.
That's right.
That's
right.
probably
We
what
put
it
that.
is.
We
Yeah.
put that there. No, that's right. That's all right.
Well,
That's all
but
right.
but there will still be two. There will still be two things that it's going to output, because by step 9 it'll be outputting the content at location 50, and then at step 10, then it will be outputting the content of location 2D.
Oh man.
So even if I don't need to know what is on the data bus, you will still need to reflect the content of two different memory locations are presented on the data bus. One on step 9 and one on step 10. Because this is immediate. This change.
It immediately changes it. It's already
Yep.
it's already set to
Yep.
be at that location, and
Yep.
then you change location in the midst of that location.
That's correct.
I get it.
Every point counts on this exam.
I know. I felt like I was really clever, like figuring it out.
Well, we'll see about the distribution of the grade and stuff like that first. So I might change nudge grades a little bit. Question number 5. So this one is just a straight subtraction thing. You just have to do the longhand subtraction. 0, 1, 1, 0 minus 1, 1, 0, 1. Okay, so you just have to give me the whole thing. But what will give you points would be this row here. Okay. So we have a default of 0, because it's the least significant digit. 0 minus 1 is a 1 with a borrow of 1. 1 minus 0 is a 1. 1 minus 0 is a 1. 1 minus 1 is a 0. It's a 0 here. 1 minus 1 is a 0. 0 minus 0 is a 0. 0 minus 1 is a 1 with a borrow. Oh, there's a 0 here as well. And 1 minus 0 is a 1. So the correct answer would be these 4 bits. Well, I guess this one too. That's the least significant bit, or the carry. Is that okay? Or
So, does it
Yeah.
help if I wrote this the same way as you, but didn't square it?
if you write it like this, I know which row to take out.
Okay.
Okay. Any questions about this one? No questions. So the reason why the actual answer is not going to carry any points is because you can get to that one using a calculator. So if you can get to it with a calculator, I don't want to assign any points to it.
So there's no final borrow?
Huh?
There's no final borrow?
The final borrow is this one here.
Oh, okay.
Yep. Mm-hmm.
What if we only display the final borrow?
Say again?
What if we only show the final borrow?
Only show the final borrow. Then it won't do it,
Yeah.
right? Specify all the borrow bits. Point values are assigned only to the borrow bits, so once again it's plural. So it refers to all the borrow bits, not just the final borrow bit. Okay, question number 6. Now, question number 6 is an interesting one because this architecture is also found in DSPs or digital signal processors. Because in digital signal processing, a lot of times they need to do a multiplication and then perform an add. If you don't have this kind of specialized architecture, then it would take 2 clock cycles, one to perform the multiplication and then the next one to perform the actual addition. By making this architecture kind of like specialized, it can do everything in one single clock because you can multiply, take the product, and then do the addition, and then take the sum and then store the sum back into a register as a result. So DSPs, digital signal processors, typically have specialized hardware, kind of like this, in order to speed up calculations. Yep.
The multiplication was commutative in this case, right? So you had multiple answers?
Yes, multiplication is commutative, which means you can specify. So you can flip, okay, which one specifies, a register, which one specifies the other register. So that's why there are usually 2 ways to specify, and the same thing with addition. But addition cannot really work out the same way because one has to come from the result of the multiplication. So the other one has to come from the register, the designated register. So there's you cannot flip the multiplier.
That was a multiplication.
What?
Oh, that was multiplication, yeah.
That's multiplication. There's a cross here. I mean, an X. Because some people see that cross too. Okay, so the question is, I want to perform C plus equal to A times B, D plus equal to A times C. So we'll go ahead and write down the question, and then we'll work out the bits individually. D plus equal to A times C. Okay, there we go. So we then we revert back to the picture here. So what we need to do is to specify A to go into one side of the multiplier, B to go into one side of the multiplier. So that would be. So it's really just a matter of reading which control lines go to which mux. So we can see that this mux here is coming from bits 2 to 3. So the best way to work on this one is to use a bit orientation. So you just spell out bit 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 bits here, okay? Because this way it's easier just to fill in the zeros and ones, and you can turn in the answer as a binary number. So I would say this is the more intuitive way to do it, but for those of you who want to use hexadecimal numbers, hey, not a problem. All right, so for the first operation, I want to specify A using the mux over here, the top mux. That's one way to do it. So bits 2, 3 is going to specify 0, 0. And then I want the bottom mux to specify the other register, which is 0, 1. And those go into bits 4 to 5. Okay. 0, 1, like that. Okay. Any questions at this point? No questions? Okay. So the register supplying for the summation and the register that is updating are exactly the same. Okay, so in both cases they are register C. Register C has an address, quote address of 10 in binary. So that means bits 0 and 1 is going to be 10 to specify register C. We also want the input into the decoder to also have the same content. So bit 6 to 7 is going to be the same, which is 10. And then bit 8 has to be a 1 in order to enable the decoder. So you need an extra 1 here. Is that okay? So that's the first location. As I said, you can interchange these two, and it will still perform the same operation because multiplication is commutative. Okay. Any questions? If you want to convert this into a hexadecimal number, then you group the bits by 4, but you have to work your way from right to left. Yes?
I didn't write the location, but I specified that binary value correlated with C plus equals A times B.
Yeah, that would be fine.
Okay.
Yeah. Ideally speaking, you want to specify this is location 0 in the ROM because I need to know the sequencing of the byte of the words. Okay. So the next location is to perform this particular operation. You just have to say, okay, it's going to be A. So these two we are keeping, and we want register C to be the other one. So instead of a 0, 1 here, whoops, I think I misplaced the numbers. So this one we keep, this one is now a 1, 0. And then the other register has to be a D, which means we need to specify 1, 1. So we have 1, 1 over here and 1, 1 over here. And then you still need the enable to the decoder to be turned on, because otherwise it won't update the register. So these are the two locations. Are there any questions about this? So once again, these two can exchange without actually changing the result. Yep. Okay, so to convert this into a hexadecimal number, we basically look at we group the bits in groups of 4, and then we have to read from right to left. So this would be the same thing as 0x192. This would be the same as 0x1. I think that's a C. That's an E3. There we go. This is an E. That's a 3.
We're reading right to left, right?
Right. So this is a 3. This is an E, and this is a 1.
Oh, okay. I see what you mean.
Yeah. But you can also exchange these 2 bits, or these 2 chunks of 2 bits. So if you exchange those 2, then this can also be 0, 1, C. 1011 is a B. I think. 1011 is a B. And then this one you can also exchange these 2, so it becomes 0x, and then we have an 8, 1, 8, 6. There we go.
So what you did is you read right to left and convert, but then you still put it on the left side.
Right. The most significant digit is always on the left-hand side.
Okay.
So you can either specify 0B for binary, or you can use 0x for hexadecimal. Your pick. So that's the entire test. Any questions? Yep.
When's the next one?
When is the next one? That's a very good question, because we got this one a little bit late, so we have to compress the time between now and the next one.
So is there one midterm and then the final?
There'll be one more exam and then the final exam.
3 exams total.
Sorry?
3 exams total.
Yep.
Out of how many points was this?
This is 20% of your final grade.
There were 22 points on the exam, right? You were 22 points on the exam?
Yep. As I said, the numbers can be very odd. And then for each question, depending on how I assign the weights, how I assign partial credit, you can get like 1/7. They can go by 1/7 of a point or something like that. Well, since Moodle is doing all the calculations, I don't need to deal with it, right? I can have as long as it's a rational number, it's good. Are there any questions about this test? All the questions?
Yeah, I did not start on number 6.
Sorry?
I did not really start number 6.
Okay.
Like I barely started it.
Okay. Alrighty. No questions?
What was the answer?
So I hope 6 is not weighted.
Oh, I got it right. Oh, wait.
I'll stay right.
Okay, yeah. We do.
The binary.
I have a question mark.
A question mark? Wait, how can you have a question mark?
I have a question mark.
None of these bits can be a question mark. They all have to
If
be.
we put question marks, but then we convert it to hexadecimal and it's correct, your A mark is down. I'm just being question marks.
I will take a look, but basically, if you get the answer correct here,
Yeah, I got those.
then you will get, you should get the credit.
Lesson learned, there's no question mark.
Yep. Mm-hmm.
Still, we can leave it in binary.
Yeah, you can
No.
use, you can either use binary or hexadecimal as your answer.
Yeah.
But I think this one is fairly close to the practice exam in many ways.
It was.
Yep. Mm-hmm.
Yeah.
Say again?
And I knew it was only 8. I'm
Okay,
like,
hold on, guys, guys. Okay, go ahead.
How did you choose a decoder to multiply the two at the same time? Because it's almost like
But we are only storing the sum into one register. So when you look at the final result here, the sum of the product and one of the existing registers is going back to the registers.
that's where I messed up.
Okay. All right.
Oh, I get it.
Yeah, so it really is very similar to the design in the practice test, except that I added this one extra thing to it, and also changed this from an adder to a multiplier, and it moved the adder all the way out here. That's the only
Something
change.
similar to this is going to be on the final.
In the final exam, it's going to be more of a assembly programming kind of thing.
Oh, that's good.
Yeah, so this is kind of maybe perhaps the last time I would have these as a question in an exam.
All right, that's good because this is crazy.
Well, this stuff is actually
Looking at a
kind
picture
of.
is very crazy.
Oh, okay. You're not the pictorial kind of person, visual. But this is actually what's happening inside the processor. So in many ways, it is important. Hey, any questions? I thought the exam was not too bad. I didn't make it too bad.
Even for my dumbness. So how much more I lose for the question marks?
Sorry?
What's going to lose for the question marks?
Question marks? Did you get the final answer right?
Everything's correct. It's just it's this.
So why don't you put a question mark over here?
I was thinking. I was very confident that like the binary number I represented was happening, whatever.
Converted it to hex. Didn't you have a table for hex? Or no, you didn't make one?
You can make one. You can make one during test.
I know.
I did have a table.
Yes.
But
I guess my only question at this point is for question 4.
Yeah.
If we missed the first write out
Yeah.
on step
The
9,
first read operation?
Yeah, the first read operation. So how much could we possibly be deducted for that? Do you have an
Not a
idea?
whole lot. You know, maybe a sixth of what the question is worth entirely.
Okay, the question is 4 points, so less than 20?
It'll be less than a point.
So look, this was like part of my answer too. I get this. This helps me build my answer.
That's helpful. That's what you need.
And then I wrote it.
I was thinking more less than 21.
So are there any questions? And don't forget, how the letter grades are assigned. Remember, 37.5% is a C.
What?
It's a B.
Huh?
What's a B?
62.5% is a B.
What's your A?
Huh?
What's your A?
A's are 87.5% or more.
That is my goal.
That is I want an A. I don't want a B. Or too hard, man. It's not good.
No, this is one of those classes where I'm really aiming for.
Yeah.
Wait, what's C again?
A C, what do you mean by where it ends?
What's the
The
percentage?
range? The range of a C is 37.5%, and then
37.5%.
37.5% to 62.5% is a C.
Grading like in
That's the
extended
minimum.
class.
Is a C.
Yes.
37.5.
Yes.
37?
Out of the whole thing.
Huh?
Out of the whole.
At the end of the semester,
At the
I
end of
add
the
up all the
semester, all the
points, and then I calculate the percentage that you have earned.
Whose homework and.
Yes.
Oh wow. And
If I don't say anything.
so basically, if I miss like 10 points on here, I can still get more
You
than
should be getting a C.
more than a.
Like my error is.
I can still get more than a.
But remember how I
What's the
assign
meaning?
points. The way I assign points is based on the A, B, C, D, F for each question itself. So I will have to decide whether you understand the concept or not.
I don't want
Will
that.
there be extra credit on
No,
the
I
final?
am.
No.
I want this. I am shocked.
No extra credit.
I get it now.
Okay.
Yeah, that's. I got confused by the
Reverse the
I
grade.
see.
big structure.
Run an A, but.
I'm not a fan of the big structure.
Okay.
Need more practice on that. And what's the
No,
B
the
again?
in work.
Huh?